We're going to be looking at applications of exponentials and logarithms. So first formula that we're going to look at is just a simple interest formula. So your simple interest formula is the following. We have I, the interest that you're going to pay is equal to P times R times T. So I is equal to the interest. And I guess not necessarily that you're going to pay. If you borrow money, that's the interest that you're going to have to pay on what you borrowed, but you might be saving money. And so that could be the interest that you're gaining on your savings. P is equal to your principal. So this is the amount you're either borrowing or you're investing. R is equal to your interest rate. So normally it's given to us as a percent. But when we're using our formula, we want to rewrite their percentage as a decimal. So rewrite percent in decimal form. When using the equation. And then T is equal to time, usually years. And so let's look at an example with that. But before that example, let's look at one more theorem. And that theorem is where we have compounding interest. And so if your interest is compounding, so compound interest formula. So our amount that we're going to get back, or the amount that we're going to owe, depending on if you're investing or borrowing, is equal to P all times the quantity 1 plus 1 over n. Sorry, not 1 over n, r over n. And this is all raised to the n times t exponent. So E is equal to the amount owed or given. P again is equal to our principal, so the amount that we're borrowing or we're investing. R is equal to our interest rate. Again, we want to rewrite that in decimal form when we're using this formula. And T is equal to time. N is equal to the number of times compounded per year. So let's look at an example. Actually, before we jump into the example again. So if they were saying it's compounded per annum, that means once a year. If it says it's compounded semi-annually, that's twice a year. If it's compounded quarterly, that's 4 times a year. There's actually one other formula, so maybe we just state that too. If it's compounded continuously, then we're going to use the following formula. A is equal to the amount that we're going to get back or we owe is equal to P, our principal, all times our exponential function E, and that E is raised to the R times T. R again is interest rate, needs to be in decimal form, and T is time, number of years. Now you got all the financial formulas for compounding. So pulling out a question to use this. So the example in front of us, we're going to invest $300 at 12% interest. We're given that it's going to compound monthly. And we want to find out what is the amount of the investment after 1.5 years. Okay, so since it's compounded monthly, the number of times it's being compounded a year is 12. Our interest rate needs to be in terms of percent. That percent needs to be in terms of a decimal. So 12%, our rate is 0.12. So divide your percent by 100 to get the decimal form. And we're given that our time, T, is equal to 1.5 years, or another way to write it in decimal form is 1.5. And our amount, our principal, P, is 300. So using our formula, our amount is equal to our principal, 300, all times the quantity, 1 plus our interest rate, 0.12, divided by the number of times compounded, 12, all raised to the n, 12, times how long we've invested it, which is 1.5. So A is equal to 300. 1 plus 12 goes into, well, I know 12 goes into 12 once, but so 12 goes into 0.12, 0.1 times. And then I have 12 times 1.5, and so that is going to give me 18. So my amount A after 1.5 years is 300, all times 1.1, and that's raised to the 18th power. So I need a calculator. So plugging that in the calculator, I'm going to round to the nearest cent. And let me just look at this really quickly. And I was a little off. That 0.12 divided by 12 should be 0.01. Okay, so we have 300 all times 1.01. That 1.01, that piece is raised to the 18th power. And getting our answer, we have $358 and 84 cents. So if they asked how much interest was gained, well, we invested $300, so $358.84 minus 300. So the interest gained is $58.84. So the next example we have is find the principal if we want to get $300 after 4 years and it's compounded daily. So we know what our amount is. Our amount is A, is 300. We know what our time is. Our time is 4 years that we're investing. And it's compounded daily. So for the financial market, for banks and stuff, they use 360 days, because it just is, I guess, an easier number to work with per year. And I must have missed out how much was it was 3% compounded daily. This is at 3%. So I know my R value is 0.03. The number of times it's compounded is 360. And I'm trying to find how much I need to invest. So I need to find P. So let's go in and plug it into our formula. We know our amount, which is 300, equals the principal P all times 1 plus the interest rate, which is 0.03, divided by the number of times compounded per year daily, so 360, all raised to the n, which is 360, times our time, which is 4. So let's simplify. With these, a lot of times you don't want to round until the very end. So we have here 300 is equal to our principal, which we're trying to find, P, all times, well, 1 plus 0.03 divided by 360. So I'm not going to really round, but I'm in my calculator, but I'm going to put it in here for you. That is 1.0000083 with a bar over it, raised to the 4 times 360 is going to give us back 1,440. So let's raise that number I just gave you to that 1.0000008, with then the 3 repeating, raise that to 1,440 power. Again, I'm not going to round to the very end, but while I'm writing it out, I'm going to round. And so here I got P times approximately 1.12749. And I'm going to divide 300 by that answer. And something was wrong. So let me plug it back in. So we get back that P, the amount that we need to invest. I'm going to round to my nearest cent, is $266.08. So if you want $300 back after 4 years with the following conditions, we need to invest that amount of money. So other types of applications that you're going to see is exponential growth and exponential decay. So your exponential growth formula is A sub t is equal to A sub 0 times e to the kt. So A sub 0 is the initial amount. A is equal to the growth rate if k is greater than 0, and it's equal to a decay rate if k is less than 0. And t is equal to our time. And then A sub t would be the amount that we would have with those conditions. So we have an example in front of us, a radioactive decay problem We have iodine 131 is a radioactive material that decays according to the function A sub T equals A sub 0. E is raised to the negative 0.087 T, where A sub 0 is the initial amount present. A is the amount present at time T in days. Assume that a scientist has a sample of 100 grams of iodine 131. So what is the decay rate? So that is the exponential piece. And the decay rate is negative 0.087. Putting that in percent form, this is equal to negative, multiply this by 100. So this would be actually not 0.8, it would be 8.7. So negative 8.7%. So how much iodine is left after 9 days? Okay, so we have our formula. A sub 0, or A sub T, is equal to A sub 0, the initial amount, and we're given that our initial amount is 100 grams. All times E raised to negative 0.087 times time, and in days, and this is in 9 days. So you're just going to want to plug that into the calculator. So take your E function, raise that to the 9 times negative 0.087. Take that answer and multiply it by 100. And you get back 45.7 grams remaining after 9 days. So when will 70 grams of the iodine be left? So we want to know when the amount A sub T is equal to 70. So we have 70 here is equal to how much we originally started with, which is 100. E to the negative 0.087, and we're trying to find our time T. So we want to isolate the E. We want to get rid of the 100 that's in front of the E, that coefficient. So divide 70 by 100, we get 7/10 is equal to this E raised to the negative 0.087 T. We want to find T, so we want to take the log or natural log of both sides. Well, the natural log of E is always just its exponent, so let's take the natural log of both sides of our equation. So we have the natural log of 7/10 is equal to natural log of E is just its exponent, which is negative 0.087 T. So now we can get T by itself by dividing both sides by that negative 0.087. So we get that T is approximately, so natural log, make sure you put parentheses around the 7 divided by 10, and that parentheses, and then divide it by the negative 0.087. We get that T is approximately 4 days. Or 4.1 days if we want to round to the nearest tens. And then the last one, what is the half-life of the iodine? Well, half-life is how long does it take for our initial amount to reduce to half of its amount. And so our initial amount was 100. And so we want to know when is that amount's going to be 50. So part D, we're going to have 50 is equal to 100. E to the negative 0.087 times T. So if we divide both sides by 100, we get 1/2 is equal to E to the negative 0.087 T. Again, we're trying to solve for T. T is in the exponent, so we can take the natural log of both sides of our equation. Well, the natural log of E is just its exponent, so I'm just going to do that right now because we're running out of time. So natural log of E to the negative 0.087T is negative 0.087T. Let's divide both sides by that negative 0.087. So natural log of 1/2 and our parentheses divide by negative 0.087. So we get that as approximately 8 days. So half-life of that iodine 131 is 8 days.